In this video, we're going to be talking about big O notation, so let's get started. So, big O notation is basically how we can compute an algorithm's efficiency. So, when we're talking big O notation measures the algorithm's efficiency in worst case. So, if your algorithm is going to take a lot of time, it's going to say the worst case time your algorithm might take. That's what big O notation measures. Now, when we're computing big O notation, we have a couple of rules. First is we drop constants. And we drop lower order terms. Basically, here are the low order terms. So we have a list starting at big O of 1. And then that's less than big O of log n. And that's less than big O of n. Big O of n is less than big O of n log n. And big O of n squared is larger than that. Larger than big O of n squared, we have big O of 2 to the nth. And then even larger than that, the largest possible time we can have is big O of n factorial. Now, the good run times for an algorithm usually range somewhere around here. These are the good times. Now, big O of n log n would be considered okay. Now, big O of n squared 2 to the n, these ones are ones that you want to avoid. So all of these are ones that you want to avoid in your algorithm. So now let's get started with some examples. We have a program here in C++, and we want to figure out what is the runtime, or what is the time complexity. Now this is constant time. This is just an example of constant time. Since our program executes a constant number of operations, right, we're executing the operations, this is going to be big O of 1 for each line. Big O of 1, big O of 1, big O of 1. Now we can just add them. Remember, this is just saying 3 times big O of 1. Let's go to our rules. We drop constants. We have a constant here. We're dropping it. So our answer is big O of 1. So constant time is big O of 1 usually, or number of operations executed. Now, let's go to linear time. Now we have a for loop here in C++. This is executed n times, right? So we have n over here. This is executed n times, and over here, this is a big O of 1. So this can be expressed as big O of 1 multiplied by n, which is big O of n. So linear time, a for loop's runtime is the number of iterations, or n. So in this case, we have n iterations, so we have big O of n as our answer. Let's move on. We have another example here. Let's just start big O of 1. And we know this entire thing is going to run the amount of iterations, n. So this is big O of n. Now remember, we drop low order terms. Let's look at our list. Big O of n, big O of 1. Big O of 1 is a low order term in this case, so it's big O of n. Now let's check out quadratic time. Oh, another example. Now we have a nested for loop here. This for loop, the outer for loop runs n times. The inner, for each iteration of the outer one, n, the inner one runs m times. So we have big O of n m. That's how your for loop would be. So each iteration, this runs n times, and this runs m times. So we have big O of nm. Now, check out another example. We have a nested for loop again. This runs n times, this runs n times. Now, this will run, the last example ran n times m times. This is going to run n times, which is big O of n squared. For each time the outer loop runs, n, inner loop will run n times. So our answer is big O of n squared finalized. Now, that's the basic introduction to big O notation. I will talk about logarithmic time in another video about time complexity. Hopefully this video is helpful, and yeah.